And Farishta, are you taking the attendance?
Yes, Professor.
All right, all right. So think about what we did in the previous classes. So we talked about the econometric model. Always write the model with U term. So econometric model, X is your independent, which is income in our example, and Y is your dependent variable, which is your consumer expenditure consumption. So yi equals beta 1 plus beta 2 xi plus ui. And so that is our first thing, econometric model. Never write a model without a u. Remember that. So obviously these i's are nothing but observations. Let's say you have n observations, sample size n, I equals 1 to n. What is the population regression line? That line that goes through the mean of y's. That is called a population regression line. That is nothing but y is given xi, expected value of y given xi, and then you get that regression, population regression line, all the expected values, conditional means of y's, depending on the x values. And what is beta 1 is the intercept of that population regression line, and beta 2 is the slope of that population regression line. Now, what is our problem? The problem is nobody knows beta 1 and beta 2. They are population parameters, intercepts and the slope of the population regression line. What do? We try to estimate. We try to estimate that intercept and slope so that we can estimate that population regression line. When you estimate it, the estimators are called, are denoted usually by convention with a hat on top. So beta 1 hat is an estimator of beta 1, beta 2 hat is an estimator of beta 2, and this y hat is an estimator of conditional mean of y. So you have the population regression line. Now you are trying to draw an estimated line, which is sample regression line, but they are not same because beta 1 hat is not same as beta 1, beta 2 hat is not same as beta 2. So basically we are trying to find an estimator of beta 1, which we are calling beta 1 hat, an estimator of beta 2, which we are calling beta 2 hat. So we are trying to find this estimated line, which is basically a representative of this population regression line, even though they are different. But we want them to be pretty close so that this line can represent that line, population regression line. Okay, so how do we do that? We said, okay, if you draw this line, then you can find residuals. The actual value of y minus the estimated value of y. Actual y minus estimated y cap. So that is the residual. Any y value you are getting from the sample, you look at the difference between that y and the height of the estimated line. So that is the residual. How many residuals do you have? As many as your sample size. If sample size is 30, I goes from 1 to 30. Sample size is 200, I goes from 1 to 200. So if sample size is 30, you have 30 residuals. What do? You add, first you square all the residuals. Some of the residuals will be positive, some of them will be negative. You square all of the residuals, then you add them. So you square the residuals, you add them. So that summation ui hat square. Summation goes from 1 to n. I goes from 1 to n. Sample size. N is a sample size. That's called a residual sum of squares.
Professor,
Yes.
Professor, my internet connection got lost, so I did not hear what you said. Could
Yeah,
you?
this is just a summary. We are going over what we did in the last class, okay? So what I'm saying is, population regression line is not known, we are trying to estimate. Population regression line is not known means the intercept of that line is not known. The slope of that line is not known. So we are trying to estimate the intercept and the slope. The estimators are denoted by caps. Beta 1 cap, beta 2 cap. And then when you, if you imagine an estimated line and the difference between any y value from the sample and estimated y, the difference between these two is a residual. It's called a residual. If you have 30 observations, sample size 30, you get 30 residuals. And what do? Here is the key. Square all the residuals. So you get rid of all negative signs because some residuals are positive, some residuals are negative. You square all of them, you get rid of negative signs, you add them. So residual square summation. That's why it's called residual sum of squares, RSS. Summation UI hat square. Now that means square this y minus y hat with the residual, square that and add that, all the residual summation. I goes from 1 to n. So if you plug the value of y hat, plug the value of y hat, this is the y hat, estimated y, you plug it here, you get summation ui hat square equals summation yi minus beta 1 hat minus beta 2 hat xi whole squared.
Professor,
Yes.
how did we get the equation 3? Y1 hat equals to beta 1 hat plus beta 2
So
hat.
this is what, yeah, how will we get this? We will the whole point is to get this equation, okay? Right now, we don't know what is beta 1 hat and what beta 2 hat are, okay? So we are imagining a line, okay? We don't know exactly where that line is. We are trying to draw that line, okay? So if you are trying to draw a line, what do you need? You need the intercept and you need the slope, okay? Hello?
Yes, Professor.
Yeah. So we are trying to find that intercept and that slope. We just said, hey, if you had this beta 1 hat and beta 2 hat, then you could draw this line. So let's try to find beta 1 hat and beta 2 hat. Okay, that means let's try to find the intercept and slope. Then obviously we'll be able to draw this line. Right now we don't know what beta 1 hat is, beta 2 hat, but we'll find that. So it's kind of roundabout. It's saying imagine a line, meaning imagine a beta 1 hat and beta 2 hat. Now how do you find that beta 1 hat and that beta 2 hat? Different principles will lead you to different set of beta 1 hat and beta 2 hats. We are using one principle to find that beta 1 hat and beta 2 hat. In other words, to find this line. What is the principle? Principle is ordinary least squares principle. Ordinary least squares. What is the ordinary least squares principle? Choose this beta 1 hat and beta 2 hat so that this residual sum of squares is minimized. That is one criterion you are using. We don't know beta 1 hat and beta 2 hat. So now they are saying use a principle to find that. What is the principle? Principle is you will choose that beta 1 hat and that beta 2 hat that will minimize this residual sum of squares. Another principle could be, how about minimize the absolute value of ui hat? That could be another principle. So find beta 1 hat and beta 2 hat that minimizes absolute value of absolute value of yi hat. That could be also another principle. They tried that. did not give too much of good properties. So they abandoned that. They did this one. They said, beta 1 hat, beta 2 hat, we want to find, we want to choose. What principle should you follow? You should follow when you will be drawing that line, this line, the residual sum of squares has to be minimum. So that's how. That is the principle. So how do you, now you know, if you know the principle is set, and later on we will see that it gives very good properties, then it's just simple. Mechanically, you minimize this to choose beta 1 hat and beta 2 hat. Calculus is very handy in that. Calculus saying, oh, you want to choose beta 1 hat and beta 2 hat such that this residual sum of square is minimized, minimum, then you differentiate that with respect to beta 1 hat and beta 2 hat partially. So that's what you did. You differentiated this partially with respect to beta 1 hat and with respect to beta 2 hat. Set them equal to 0 because that is the first order condition for minimization. You are trying to choose some variables. They are called choice variables. Choice variables. What are the choice variables here? Hello? What are the choice variables here? What are we trying to choose? Huh? Hello?
Beta 1 and beta 2.
No, not beta 1 and beta 2. Beta 1 and beta 2 are parameters. They are unknown. We cannot find them. We are trying to find beta 1 hat and beta 2 hat. Do you see the difference between beta 1 and beta 1 hat? Beta 2 and beta 2 hat? First thing, let's agree that this line cannot be known. Okay. What is that line? Hello? Hello?
This population regression line.
Yeah, that line cannot be known. That means beta 1 and beta 2 cannot be known. So what are we doing here? We are trying to estimate. We are trying to estimate beta 1, and that's, we are calling it beta 1 hat. We are trying to find an estimator of beta 2. We are calling it beta 2 hat. Are they equal? No. Beta 2 hat is not equal to beta 2, or beta 1 hat is not equal to beta 1. So what we are trying to do is, now we are trying to choose beta 1 hat and beta 2 hat. But what is the criteria to choose them? The criterion is choose them so that this term, what is this term? Residual sum of squares is the least. That's why it's called least squares. Ordinary least squares. Least means minimum squares. Squares of what? Squares of residuals. The name is very obvious. It's telling you the criterion is choose beta 1 hat and beta 2 hat such that residual sum of squares is the least, becomes the least. So, and then if it's the case, then this is basically nothing but a minimization problem. Choice variables beta 1 hat and beta 2 hat. So you differentiate. Remember this. Even in my intermediate micro class, I always try to tell you that choice variables means you are trying to choose those variables. And how do you choose? If it's calculus is applicable, you differentiate the function with respect to the choice variables. That means you are trying to find beta 1 hat and beta 2 hat. What is beta 1 hat? Beta 1 hat is an estimator of beta 1. Beta 2 hat is an estimator of beta 2. So now if you know calculus, it's very easy. You partially differentiate this with respect to beta 1 and with respect to beta 2, set them equal to 0. basically that's what you do. Set them the residual sum of square with respect to beta 1 hat, residual sum of square differentiated partially with respect to beta 2 hat. Set them equal to 0. So two equations you get here, and from those two equations you will find two unknown variables here, beta 1 hat and beta 2 hat. Two equations, two unknown variables. These partial derivatives will give you two equations with two unknowns, beta 1 hat and beta 2 hat. Solving simultaneously, you get. Now, I did not show everything here yesterday. So you have to differentiate it, do the differentiations and algebraic manipulations to get the results. So two equations, two unknowns, please you do yourself. Do the differentiation, do the manipulation, algebraic manipulations to end up with, the book gives some hints. You try, if not, you let me know. You end up with these two values of beta 2 hat and beta 1 hat. You need 7 to 8 lines. If you need 7 to 8 lines from these two equations to end up with these two end results. Beta 2 hat, summation xi minus x bar, yi minus y bar divided by summation xi minus x bar whole square. Beta 1 hat, y bar minus beta 2 hat, x bar. Question?
Professor,
Yes.
in these, no. Can you scroll down?
Yeah.
Can you scroll down?
Yeah.
So here, where is y1, yi, or no, where is yi? Like beta 2 equals to summation of xi minus x bar.
Xi minus
So
x
where,
bar. Yeah.
then
Oh,
where is
oh,
yi? Is there
this is, yeah. This
yi?
is I. This is I. Yeah. Obviously, these are all i's. These are
Professor,
all
where does
coefficients.
y bar, x bar come from?
Yi minus y bar, summation xi minus x bar. Yeah. What is the question?
Yeah, from where does y bar and x bar come from?
So from the sample. Okay.
What sample?
So what sample? Let's think about our table. That was the population. Okay. X and Y values. Remember X and Y values, income and consumer expenditure? Do you remember that table?
Yes, Professor.
So if you collect a sample, in a sample, what do you get? You get X values and Y corresponding Y values. We'll show one sample, okay? So you draw sample from the population. Then what do you get? You get some X values and some corresponding Y values. So if you get, let's say, 10 X values, can you get X bar from there? Hello? Suppose I give you 10 values for X. How do you find X bar? Hello? Huh?
We'll add all the numbers and we'll divide those number by that number. It will,
But by which number?
like if you gave us 10x, that means we have to add 10x and we have to divide by 10.
Exactly.
It's
What do we call it?
But
Average.
Professor, this is average.
That is average. That is sample mean.
Is that X bar?
Yes.
Okay.
Don't you know X bar and Y bar?
No, forgot.
You don't know sample mean?
I knew the average, but I forgot this thing.
You forgot mean, average.
No, not average, the bar one.
Oh, okay. Oh, you don't know how they're going to denote. Yeah. When you see bar,
Yeah, I knew the average mean.
that
I
is
know.
nothing but a simple mean, simple arithmetic mean, a sample mean.
Okay.
Anytime you see a bar, you know that this is a sample mean.
Okay.
So any questions so far? Once again, quickly look at this. You have this econometric model and this population regression line, which is nothing but the expected value of y, conditional mean of y. That is a line, population regression line. All the expected values of y, all the conditional means of y on the line. We really are interested in that line. We want to know beta 1, we want to know beta 2, so that we can draw that line. How do you explain beta 1? Can anybody quickly explain beta 1? Hello? Hello? Ashley?
Yes, Professor.
Ashley? Miss Ashley Biju, are you there? No.
Professor, beta 1 is the intercept.
Okay. Can anybody go ahead and volunteer to explain beta 1 and beta 2? Hello?
Professor, beta 1 is intercept, right? And
Yeah.
beta 2 is the slope.
Yeah. That's true. But how do you explain that intercept? And how to explain that slope? Hmm? Don't leave, please. These are way too important things. Farzana? Hello, Farzana?
Professor.
Yes. Are you there?
Yes, Professor.
How do you explain this beta 1?
Beta 1 is Professor intercept.
Beta 1 is what?
Intercept.
Yeah, intercept. But how do you interpret that?
Professor, when x equals to 0, y equals to beta 1.
No. Can't you see this left hand side? What is this left hand side here? Huh? Can you see this left hand side? Hello? How many times I'm telling you? Expected value of y given xi. What is that? Hello? Hello?
Yes, Professor.
Yeah, so what is this? Expected value. So how do you explain beta 1?
So, sir, Professor, do we say, for example, if x equals to 0, then the intercept is the expected value of y at that value?
Exactly. When x equals 0, you already said x equals 0. If x equals 0, conditional mean of y equals what? Beta 1. Now, how do you explain beta 2?
If we increase x by y by 1 unit, then x increases by beta 2.
Which one you are increasing first?
If we increase x by 1 unit, then y increases by beta 2 units.
Again, you are saying y. I'm very sorry. Are you guys with me here in this class? What am I saying here? What is here?
Expected mean.
Expected value of y, conditional mean of y. Say it again, please. How do you explain beta 2?
If we increase x1 by 1 unit, then conditional value of y increases by beta 2 units.
Conditional value? No, conditional mean.
Mean of y, sorry.
Okay. I'm not sure if you guys are listening to me when I'm saying it is there. I told you the expected value. It's all conditional means. At least I told in this class at least 20 times that population regression line is nothing but all conditional means of y's. So beta 1 means when x is 0, conditional mean of y is beta 1. If beta 2, How do you explain beta 2? If x increases by 1 unit, conditional mean of y increases by beta 2 units. All right. Sorry about this, because this is way too important. The core of regression. Regression gives you only on average result, mean result, not individual result. Individual y, we don't know. We only can know about the mean values of y's. So estimated line is also basically trying to mimic this population regression line, but it is not exactly same as population regression line, but it's really trying to mimic that one. So when you say beta 1 hat, then you are saying when x is 0, average y, on average, y is beta 1 hat. And how do you explain beta 2 hat? If x increases by 1 unit, y on average increases by beta 2 hat units. You have to say on average. This is an average result, mean result. All right. So residuals, and then when we think about this estimated line, then from that estimated line, each y and that estimated line, the height of that estimated line, the deviation between y and then the height of the estimated line is called residuals. And then what we do, some residuals are positive, some of them are negative. You try to get rid of the negative signs. One way of getting rid of negative signs are squaring them. So you square all of them, positive or negative, you don't care, you square all of them, and then you add. So that is called residual sum of squares. You square the residuals and add all the residuals. That is called residual sum of squares. Now you want to draw that line such that these RSS, residual sum of squares, is the least, is the minimum. That's why it's called ordinary least squares method. Ordinary least squares, OLS methods. Now it's very simple. Choose that intercept, choose the slope so that that residuals sum is minimized. And then you resort to calculus. You differentiate partially with respect to beta 1 hat and with respect to beta 2 hat, set them equal to 0, because first order condition for minimization is all these derivatives have to be 0. Once you do that, if you know how to do differentiate, you end up with two equations, and then you find these two unknowns, beta 1 hat and beta 2 hat, which are the estimators of beta 1 and beta 2 respectively. Beta 1 hat is an estimator of beta 1, beta 2 hat is an estimator of beta 2. And with the algebraic manipulation, you end up with these two formulas for beta 1 hat and beta 2 hat. So now the question is, how do you get those xi, x bar, yi, y bar? Obviously, you have to resort to sampling. You have to collect sample of x and y. So you ask a family, let's say that family has income 80. You ask them, your weekly income is $80. How much do you spend? Then the family might say 70 or 75 or 60 or 65. All of them are equally likely cases. So you might end up with a family that spends 70. Then you ask another family with 100 income. Your income is 100. How much do you spend? Then you know that from the table, big table, population, there are many families with that income, 100. You pick one family and they tell you the income. So let's show that sample. Let's show that sample to you. Now it will be clear to you how they actually, this is the first time and last time I'm showing you this thing, because later on you will see that really it's not as So I copied those. Can you see this Excel sheet here? Hello? Hello?
Yes.
Yes, Professor.
Yes, Professor.
All right. So I copied that formulas. Better two head. Summation xi minus x bar, yi minus y bar divided by summation xi minus x bar whole square. Beta one head, y bar minus beta two head, x bar. That's why I put beta two head first. Once you know beta two head, then you can find beta one head. Easy formula for it. So here is the sample. Look at this. You collected this sample. Yeah, up to this, sorry. Up to this. So how many observations are there? Can you count? Hello? How many x values?
10.
Huh?
12, Professor.
No, not the last two.
10.
Or
Yeah.
10.
Yeah, last two are summations and means here. Last two, these are not. Yeah. So first 10 here. Look, 80, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now actual sample. Okay, let me explain the sample here. So you ask a family with income 80. How much is your consumption? The family says $70. You ask a sample with 100, a family with 100 income. The family says I spent 65. Family with income 120 spends $90. Family with 140 spends 95, and so on. So 10 observations. So n equals what? N equals, hello? N equals 10.
10.
Sample size 10. You will see that these numbers are all coming from that big table I showed you in the past. That big table is a population. Remember the first one where income equals 80? There were 5 families with income 55, 60, 65, 70, and 75. Remember that? If not remember, you can check your book. You see that with one value of x, there were 5 values of y. When you collected the sample, one of those 5 families you have picked. You have picked that family with spending 70. What is the probability that the family will spend 70? 1/5. 5 values of y with 1 x value. All values were equally likely, meaning with same probability, and the probability was 1/5. You picked one family, that is sampling you are doing, that family spent $70. Okay, it could be 75 also, it could be 55 or 60 or 65, but you pick this one. You go to another family, there you ask, how much is your income? 100. How much do you spend? You said 65. There were many families in this income group, and with different spending, you picked one. So and so on. So you collected this sample of size 10. Here is income, here is expenditure, consumer expenditure. So which one is independent, which one is dependent? Hello?
X is independent and
X
Y
is
is
independent, Y
dependent.
is dependent. Now the formulas are here. I did it almost like manually, so you can see what is going on. Forget about these last two. I'll color them if I can. Is there possible to put color here? Yeah, I'll put color here. So what do we need? We need xi minus x bar, yi minus y bar. Okay, so yi minus y bar. I try to find yi minus y bar. I'll go step by step. Please, if you have any question, you ask. Okay. So what is so first value? What is y? Y is 70. What is y bar? How do you find y bar? Hello?
Professor, add the values and divided by the number of values.
Add all these values, okay? 70, 65, 90, 1000. So here's the summation of y.
Divided by the 10.
Yeah, so look at this.
Total
11,
of the
10. How did I get it? I got it with summation of these two, these, all the values I added. Do you see that? Here,
Yes, Professor.
summation of D5 to D14, D5 to D14. So I added all the values. And then what is this? This is the average, meaning you can have average function also in this Excel, or you have already added, then you divide that summation by 10. I could do that also. I could do this summation by 10. Still you get the 111. So y bar is 111. So what will be the first value? Y minus y bar. What will be the first value here? 70 minus 111. Okay, you see?
Professor,
Yes.
just for clarification, can you highlight where the y bar is? Like when
Where is
we
the y bar? Look at
can
this.
you
This
no
summation.
can you mention where the y bar is? Just because just when we see the lecture later, so we can understand it a bit better, like where the y bar is supposed to be placed.
I get it. What are you trying to say? I'm sorry.
I'm saying
Yeah.
can you mention where the y bar is? Like we understood where the y bar is, but just for clarification, can you mention it in the table where the y bar is?
In this table here.
Yes, can you write it down, like where the y bar is? Just for understanding.
How do you write y bar here? Can you write y bar here?
No. Like I think it beside the mean, or I don't know. Like
I wrote mean here.
Yeah, Professor, you can write beside the mean.
Huh? Where do you want to write?
Beside the mean, you can inside the bracket.
Yeah,
You can
that's what
mention that the
I
y
wrote.
bar.
Look at this. What did I say here? Huh? Here, these two values are means. That's what I'm trying to tell you. You see, these are summations. These are what? Means. So what is 170? Huh?
X
What
bar.
is X bar? How did you get X bar? You added all of them divided by, so here is summation, and divide that by 10, you get 170. In Excel, you can use this summation sign or average. In calculator, what do? You add all of them, you get the summation, you divide by sample size, and 10 here, you get mean. So here the mean of X, mean of Y. You should remember this thing. What is there to remember? Y bar is summation Y over N, X bar is summation X over N. Simplest possible statistics in the probability statistics. So anyways, so how do you get these values? The first value, this minus mean of this, y minus mean of y, y minus mean of y. What is y? Y is here 70, D5. This cell is D5 minus the mean 1, 1, 1. What is this? 65 minus 1, 1, 1. What is this? 90 minus 1, 1, 1. And so on. So what is this 44? Let's say 44 is 155 minus 1, 1, 1. Do you have any question about this column? You have to tell me if you have a question how to calculate y minus y bar. Hello?
No question.
No questions?
No.
Anybody got any question? Please speak out now. These are the easy calculations. You use your calculator, you find them. I'll let you do that. If not, then how about this? X minus x bar. First x is 80, okay? So 80, what will be this x minus x bar? Tell me.
Professor, it's 80 minus
170.
80 minus
170.
170. 80 minus 170 minus 90. What is this? 100 minus?
Minus 170.
100
minus 170.
Yes. This one, 120 minus
170.
170. Here you see. What is this?
But Professor, why this is 0? It should be,
It cannot be 0. It cannot be 0.
yeah, it will be 10.
It will be 160 minus 70.
Minus 10.
Yeah, minus 10. Okay, I think our result will change a little bit. Anyways, not a big deal. So, you know now, what is this? 200 minus 170.
170.
220 minus 170 and so on. So any question about this line? This column?
No, Professor.
We will be just learning how to do this with a calculator. You have to do it with a calculator. No questions?
No, Professor.
Okay, let me go over again. First thing, you want to find x bar and y bar. What are they? They are sample means. X bar, sample mean of x, y bar, sample mean of y. How do you find x bar and y bar? From probability statistics, we know that it's a sample mean. You add all the values and divide by the sample size. Summation of x bar equals summation of x over n. Y bar is summation of y over n. So we use that formula here. We sum first, then we divide it by sample size. We got the sample means. Remember, they are not population means. Nobody knows what population mean is. We are just looking at sample mean. So y minus y bar, x minus x bar. So how do you find x minus x bar? Obviously, you have all x values, 10 x values. You also have x bar. So from all the values, you subtract x bar. You get this x minus x bar. How do you get y minus y bar? You subtract y bar from y, not the other way. Don't do y bar minus y. We are doing y minus y bar, not y bar minus y. We are doing y minus y bar. Okay. So far, so good. Hello? So far, so good?
Yes, Professor.
Okay. So let me ask you a question. If you recall anything from your probability statistics. If you add this whole column, what will you get? What will you call it? And what do you get? Huh?
Professor, what do you say?
So let's say, what are these values? Y minus y bar. If you add them, what do you get? What should you get?
The summation I will get.
Summation?
Yeah,
What do you get here? What do you call it?
summation.
Summation of what? Y minus
Y bar.
y minus y bar. What do you get here? Summation of
X minus X bar.
x minus x bar. True. This is summation of y minus y bar. This is summation of x minus x bar. Let me write it here. Summation of, let's see if I can copy from here. Yeah, summation of xi minus x bar here. This is what you are saying, okay? And also here, what is that? I'll copy.
Summation of Y minus Y bar.
Huh?
Summation of Y minus Y bar.
Summation of, I'll erase this. This is summation of y minus y bar. This is summation of x minus x bar. Everybody with me here? That this column is basically nothing but summation of this, and this column is summation of this here.
Yes, Professor.
You are right. You are okay. Miss Lovely Akhtar, why do you have two IDs here? Lovely Akhtar. Hello, Lovely. Okay, Lovely is quiet with two IDs. Okay. Mima Jahan, are you there? Mima Jahan?
Yes, Professor.
Hey, Mima. Are you there?
Professor.
Did you do probability statistics?
Yes, Professor. Yes.
So let's focus on this. What do you think about the summation of this column? Should be.
Professor, the summation of this column will be x minus x bar.
Yeah, true. That's what I wrote. But what will be the value of that? Anybody got any guess? The whole class?
Will it be zero? Professor, will it be zero?
Exactly.
It will be zero.
It will be
Zero.
zero. What will be the value here? What will be the value there?
It's zero as well.
Zero. Exactly. This is a property of arithmetic mean. If you have done arithmetic mean in your probability statistics, you know that summation of deviation from arithmetic mean is what? Summation of deviation from arithmetic mean is zero. You can show it in two lines. I will not show you, but this is an example here. So summation of deviation from arithmetic mean for y or for x, it will be always zero. So this column sum will be zero. This column sum will also be zero. What is there in the numerator? Beta 2 hat. We are trying to find beta 2 hat. What is in the numerator? Hello? What is there in the numerator? Read it for me, please.
Professor, is summation of x minus x bar square.
No, in the numerator, not denominator.
Okay, a summation of x minus x bar into summation of y minus y bar.
So will that be zero?
Yeah.
Huh?
Yes, Professor.
So if the numerator is 0, beta 2 hat will be always 0.
It
Huh?
should be, right?
So
Okay.
what is the point of doing all these things if we know that slope is always 0?
It could be changed, Professor.
Huh?
It could be changed sometimes.
It can be
Changed.
10. How do you say 10? If
Professor, if there are like there are 10x value, right? So if we
10x,
add
what did I say here? Summation of xi minus x bar. What should you get?
0,
So how about the numerator here?
0,
Will you get always 0?
it might be changed, Professor.
10? How do you say 10? You are saying, theoretically speaking, summation of xi minus x bar equals 0. Summation of yi minus y bar equals 0. Irrespective of whatever x bar and y bar is, it will be always, summation of deviation from arithmetic mean will be always 0.
It will be 0.
That means beta 2 will be always 0.
But no, don't say beta 2. This is beta 2 hat.
Yeah, beta 2 has.
Never match these
It will
two
be 0.
things up.
Yes, Professor, beta 2 has.
Yeah. So beta 2 hat will always be 0.
Yeah.
Any other thoughts? Anybody else wants to say anything? Anything else? Hello. Are you guys with me here? What I'm trying to tell you?
Professor, if the summation of y minus y bar and x minus x bar is always 0, then beta 2 hat should be
Then beta 2 hat will always be 0. That's what you are trying to say?
yeah.
Okay. Sunam Yuden, what do you think? Sunam? Hello, Sunam. See, I will not give you the recordings before the midterm.
No, Professor. No,
I will not give you the recordings. Nah, that's why people are just
Professor, we need recording.
taking their own.
Professor, I don't need. I took a screenshot.
Tasneem Rahman?
But we need.
Tasneem?
Yeah, we need. Exactly.
Okay, all right. Yana Lau? Yana Lau.
Yes, Professor.
So, Yana, what do you think? If summation of xi minus x bar is always 0, summation of yi minus y bar is always 0, then what do you think about this numerator of beta
It's
2 hat?
0.
Will that be 0?
Yes.
Anybody else? Can see anything else? Raisa Rahman? Raisa, are you there?
Professor,
Professor, we have to multiply before then we can say that it will be 0 or not.
Who is saying this?
We already got zeros.
Okay, okay. Yeah, actually, here, look at this thing carefully. This is not summation of xi
Professor.
minus x bar or summation of y minus y bar. This is rather summation of xi minus x bar times yi minus y bar. Okay. So what you are looking at is a multiplication, a product of these two.
Yes, Professor. We have to
Product
multiply.
of these two. Even though summation of this is 0, summation of that is 0, the summation of product can be something very different.
Yes, Professor.
So the next column is xi minus x bar multiplied by y minus y bar. That means you multiply these two columns. You multiply minus 41 with minus 90, minus 46 with minus 70, minus 21 with minus 50, and so on. So you multiply this column by this column, third column by fourth column, and you end up with xi minus x bar, yi minus y bar. That product column is this column. Up to this. Are you guys okay now?
Yes,
That's why I
Professor.
spent some time on this summation thing because people kind of mess these things to up. summation of yi minus y bar times summation of xi minus x bar will always be 0. But if you multiply first, then you add, then you are getting this summation numerator thing here. Okay, so we added, if you see here, this E5 times F5, E6 times F6, E6, F6, E7, F7. That means these two columns you are multiplying, and then you are getting all the products, and then you add. This is summation of all these values. Summation G5 to G14, G5 to G14. So that is that value. Summation xi minus x bar times yi minus y bar. Now what do we need? We need this one, summation xi bar whole squared. Summation of xi minus x bar whole squared. Here you have xi minus x bar. Summation of xi minus x bar is always 0. So if you square, will you get a 0? Hello? Huh? Not really. Summation of xi minus x bar whole square will always be 0. But xi minus x bar whole square, you get this square and you add, then you get this thing, denominator. Both the things are not same. So what you do? You square this column here, this column. You square this column, you got this. Look. F5 times F5. F6 times F6. That means minus 70 times minus 70. Here, minus 50 times minus 50. F7 times F7. And so on. Here you see 10 times 10 is 100. F10 times F10. So what is this? This is basically xi minus x bar whole squared column. So when you add that, then you get this summation of xi minus x bar whole square, which is this. Question. Today I'm not going to do much. I am trying to show you this calculation. You have to do it with a calculator. So do you have any question as to how to get these columns here?
No, Professor.
Huh?
No, Professor.
Is your calculator?
Yes, Professor.
Yes.
If not, then you look at this beta 2 hat. How did you get beta 2 hat? Huh? How do you get beta 2 hat? Huh? This column sum divided by this column sum. This value divided by this value. Look at the formula. Summation xi minus x bar yi minus y bar divided by summation xi minus x bar whole square. So summation xi minus x bar y minus y bar is this divided by summation xi minus x bar whole square is this. So we did it here. You see? So G15 over H15. G15 here, G15, this is H15. So G15 over H15 is 0.509. So what is the beta 2 hat? Hello?
Yes, Professor, 0.5090.
Okay, let's say 0.51. So beta 2, how did you get beta 2? You got beta 2 by dividing summation xi minus x bar y minus y bar by dividing that by summation xi minus x bar whole square. Did you get everything from this sample?
Yeah.
Do you need anything else to find this beta 2 hat?
Professor, can you repeat last sentence?
Which part?
Beta 1.
Huh?
Professor, beta 1 and
No, I didn't talk about beta 1 yes. I'm talking about beta 2 hat. How do you get beta 2 hat? Huh? Beta 2 hat.
Professor,
X minus X bar. Y minus Y bar divided X minus X bar
Y bar. What is
power
it?
2.
Yeah. This formula. I'm just trying to find this formula. Summation xi minus x bar, y minus y bar. That is xi minus x bar, y minus y bar. We added. This is that value. 16,800. Then I tried to find xi minus x bar whole square. Here, you have xi minus x bar, I squared that. So I got xi minus x bar whole square. I got that, and you need summation, I summed here. You got this. So now, beta 2 hat is the ratio of this by that. That's what we did here. Beta 2 hat is G15 by H15. G15 is 16,800. H15 is 33. What is that? 33,000. So 16,000 divided by 33,000, you got something like 0.509. Question? Hello?
no, Professor.
No questions.
No.
How do you explain that beta 2 hat now? Interpret. Let's say it's 0.51. Is it the slope or intercept?
Slope.
So how do you explain that? Okay, let me first find this one. Beta 1. How do you find beta 1? What is the formula for beta 1 hat? Beta 1 hat equals y bar minus beta 2 hat.
Beta 2 hat multiplied.
Y bar minus beta 2 hat x bar. What is y bar?
It's 111.
111. Here, 111 minus beta 2 hat. What is beta 2 hat? Here,
0.51.
0.51. So which this is H18. This is H18. Here, H18. So again, go back. Y bar 111 minus beta 2 hat multiplied by what?
X bar 170.
X bar 170. Here is X bar, which is C16. So C16. Y bar 111 minus H18, which is the beta 2 hat, multiplied by the mean of X bar 170, which is here C16. You got this value of beta 1 hat. Now you have beta 1 hat, you have beta 2 hat. Then you can write the line. Here I'll write this 45. So now, if you have beta 1 hat, you have beta 2 hat, you can write the estimated regression line. Y hat I equals 24.45 plus 0.51 xi. Is that true? Hello?
Yeah. Professor.
Yes. Everybody with me so far? How you end up with beta 1 hat and beta 2 hat?
Yeah.
So
Yes,
you see,
Professor.
this is the regression. This is what you do. The softwares will give you the results right away. But we as econometricians, we should know how they are getting these numbers. We have this population regression model, the econometric model, which have involved like beta 1, beta 2, and all this. Beta 1 and beta 2, the intercept and slope of the population regression line. Nobody knows. Now, what is the target? What do you want? We want to estimate them. Population parameters should be estimated with the help of this sample. And then you collect sample. Now, what criterion will you use to estimate beta 1 and beta 2? Then OLS says fit a line, talking about this line basically, fit a line so that the residual sum of squares are minimized. And then you know calculus, then you differentiated their residual sum of squares with respect to beta 1 head, beta 2 head. These are the things you are really finding. Then you ended up with this. With these two partial derivatives, you ended up with these two formulas. They are called estimators. Beta 2 head, beta 1 head. And here, if you look at these formulas, you can get everything from your sample. You don't need anything else. If only you know X and Y values, if you collect a sample, you have X and Y values. With these X and Y values, you can find beta 2 head and beta 1. How? We literally showed you how to end up with beta 2 head and beta 1 head. And we found that beta 2 head is 0.509, beta 1 head is 24.45. And so we then said, okay, here is our estimated regression line. Y head equals 24.45 plus 0.51 xi. Now the question is, first thing, can you draw this line if intercept is known, slope is known? Is there anybody who cannot draw a straight line when intercept is given and slope is given? Hello?
No, Professor, we can.
Everybody should be able to draw this line. I'm not going to show you. I'll ask you in the exam. Find this, draw the line. Will you be able?
Yes,
Not
Professor.
learn. Go learn how to draw a straight line when the vertical intercept is given, slope is also given. To draw a straight line, how many points do you need?
2.
2. Okay, let me give you first point. If x equals 0, what is y? Y hat here. If x is 0, what is y hat? Hello?
Yes, Professor.
If x equals 0, what will be the y hat?
24.45.
It will be beta,
So
beta
that
1.
will be one point, okay? Can you find one more point? Let's say
Yes,
x
Professor.
equals 4. Then what will be the y hat?
We have to multiply first, then add.
Yeah, so multiply 0.5 with 4. What do you get?
4 and add with 24.5.
2 plus 24. What do you get? Something like 26.45, something like that.
Yes.
So can you draw that line, adding these 2 points and extend? If you want to extend, you extend on the first axis, first quadrant. Yes? I'm not going to show how to draw a straight line when your equation is given, intercept is given.
Professor, it will be like more clear if you draw.
No, I will not show. You have to try it. What do you mean by I have to draw? Is a econometrics class. You learn how to draw a straight line in the first class calculus, in the access class.
Okay.
You are given an equation you draw the line. It's a straight line. You find it. But you learn. If you don't learn, you let me know. The professor, a straight line is a mystery for me.
So professor,
Yes.
in this regression line, I have to put like for x value like 80, 100, 120 like this.
Whatever. No. You have an equation of a straight line. Is it a straight line? Is it a linear equation? Huh?
Yeah.
Yes, Professor.
So how do you draw a straight line? Huh?
Professor, there is x.
assume the x value.
What will be the x?
No, you give one x value, you will get one y.
Then I have to suppose to give the x value.
Either way, if you give y value, will you get x value? How do you draw a straight line? You need only 2 points to draw a straight line. I give you 1 point, which is if x equals 0, y equals 20.
Now you are saying if x is 0, right? But in the exam paper, will be there given the x value.
No. Why should I give you? If you
Then
end
how?
up with, if what are you saying here? I really don't see the point. If intercept is given, slope is given, how do you draw a straight line? I don't see your point here, really. Okay, let's say from this, if
Professor, we can assume any point, like
any
assume
point,
like x is
any point,
equal 1 or
don't
2
imagine
like that.
negative points, because these are income and expenditure. Okay, so let's say x equals 100. Then what is y? Y hat here. I write y. What is y? Huh? Y is 24.45 plus what? 0.51
0.51.
multiplied by what?
100.
100. That is y hat. Another point. X equals 0. I'm considering x equals 0 because that has x. Y would be what? This is not y. This is y hat. Remember, the height is y hat. Y equals. So that is another point. Can you add these 2 points? Huh?
Yes, Professor.
Yeah. So, what do you want me to teach here? I cannot teach these things really.
Professor, you write the x value 100 here.
Yeah. How about x value 5 only? Can you do that?
No given value. Then
What do you mean by given value? Everything is given in this equation. You give one x value, you will end up with another y value. Any x value, you tell me.
then any x value we
Let's
can
say
put.
x equals 2. What will be the y? Huh? 24 minus 4, 5 equals 4, 5 plus what? 0.51 times what? 2. So what is y now? Huh? Do you see what I'm trying to say here? Did you guys really do any calculus or any algebra, geometry?
Yes, Professor.
Huh? Why do you need values when the equation is given? You give me any y value, I'll give you an x value. Because the equation is given. But you need really only 2 points. And you can extend it. Okay. Okay, I'm not gonna in there. It's but you learn, if you practice it, you learn it. That's not my kind of interest. My interest is how do you explain beta 1 hat, which is 24.45? How do you explain interpret beta 2 hat, which is 0.51? Can anybody volunteer? Hello? Huh? Hello.
Yes, Professor.
So how do you explain this beta 1 hat, which is 24.45? Huh? How?
When x is 0,
If,
conditional mean
if,
if x is 0,
yes.
then conditional mean of y will be for 24.45.
Yeah, this is not conditional mean. This you can say is average. Conditional mean is expected value of y, okay? But this is like a sample, like x bar or y bar. Are they population mean? No. X
No,
bar
this
is
is
not,
sample.
y bar is not population mean. Similarly, y hat is not population mean. So we call it just average, okay? On average. So if x is 0, on average, y is 24.45. One more time. How do you explain beta 1 hat, which is 24.45? When x is 0, on average, consumer expenditure is 24.45. Once again, if income is 0, if a family income is 0, on average, the family on average spends $24.45. So that is the uh, intercept. Slope, how do you interpret slope? If x increases by 1 unit, y on average increases by 0.51 unit. Once again, if income increases by $1, consumer spending on average increases by $0.51. Once again, if income increases by $1, consumer spending on average increases by $0.51. Do you have any question? If I don't see on average thing when you are interpreting, you will be penalized heavily. I will deduct 50% of the points if you don't write on average thing, because regression always do the on average kind of results. Regression cannot tell you what happens to y if x increases. Regression can only tell you if x increases on average what happens to y, or if x is 0 what is y on average, not any individual y. So are you guys okay now so far? Hello?
Yes, Professor.
Sorry, I was kind of little bit upset, but it's fine. If you have questions, you can ask. Straight line, obviously, straight line is the most important thing for intermicro, for econometrics. You have to learn straight line inside and out. If equation is given, you should be able to draw that in a straight line. You should be able to interpret. You should be able to find the slope, how to find slope, how to find intercept, and so on. So anyways, this is actually for any other social science, most of them, journey ends here. That means once you get the line, this line, estimated line, you draw it and you say, hey, I'm done. Now I know the relationship. They will end their journey here. Because what is the goal? The goal is to find the intercept, the slope. So we know if x increases, what happens to dependent variable. Like in our example, consumer expenditure and income. John Maynard Keynes says, income increases, consumer expenditure increases. If income increases by $1, consumer expenditure increases by less than $1. And then I said, okay, what do you call it? MPC, marginal propensity to consume. And then beta 1, they intercept, what do you call it? Autonomous consumption. If income is zero, even if income is zero, how much the people consume. That kind of issues. But when we started our journey, we found that between Y and X, there is no one-to-one correspondence. X increases, what happens to Y is a mystery. However, we saw that if X increases, conditional mean of Y also increases. So, and then we drawn this population regression line and said, oh, even though we don't know what happens to Y if X increases, but we know what happens to conditional mean of Y. If X increases, conditional mean of Y increases. The problem is the intercept and the slope of those population regression line is not, they are not known. They are population parameters like mu, like sigma square, like population mean, like population variance. Nobody knows them. So what to do? If we don't know mu, what do we do? Do you remember? If we don't know population mean, we resort to sample mean. Mu is not known, so we do X bar. Similar stuff here. Beta 1 is not known, beta 2 is not known, so we try to estimate them. And we call the estimators beta 1 hat and beta 2 hat. OLS principle. Choose beta 1 hat, beta 2 hat such that residual sum of squares is minimized. Then we saw that, oh, this is very easy. We know calculus. We do partial derivatives of the residual sum of squares with respect to beta 1 hat, beta 2 hat. And then we got two equations, two things to know, beta 1 hat, beta 2 hat. You solve simultaneously and you ended up with these nice formulas. Beta 2 equals summation xi minus x bar y minus y bar divided by summation xi minus x bar whole squared. Beta 1 hat equals y bar minus beta 2 hat x bar. Then, okay, we got the formulas. They are called estimators. Then what do? You go, you collect sample. We collected sample. This is from the book actually. So one sample we picked from the book of size 10. 10 x values, 10 corresponding y values. Use them for calculation. Calculated the formulas and found that beta 2 hat equals 0.509, beta 1 hat equals 24.45. Then we plugged the values in the estimated regression line. We said y hat I equals 24.45 plus 0.51 xi. We wrote the equation, then we should be able to draw the line. I did not show you, but I gave you some points. 2 points, you should be able to draw the line. So you draw the line and then explain the intercept. How to explain the intercept? Beta 1 hat, which is 24.45. We said if x is 0, if income is 0, on average, consumer expenditure would be 24.45. How to explain the slope, beta 2 hat? We said if x, that means income increases by $1, the families on average, their consumer expenditure increases by 51 cents. That's it. For any other social sciences, that's, oh, we got everything here. But for us, really, journey is the first step we have done, and then we have to go a long way. So far, I have gone so very slowly. Later on, we have to little bit pick up our pace. But I will not do any new things today because we'll do after midterm. If you have any questions, you ask. So far, anything. I'll share these two with you. The Word file, the Word one, and this Excel one, so you can see. I'll show this Word file, the one I showed, and also the Excel sheet, I hope. So I'll share this one as well. So here is there is, I think, this 4 file. Any questions? Hello.
Professor?
Yes.
Professor, can you send the last classes lectures, video lectures?
Yeah. I will send last lecture and today's lecture as well.
I
Even
think
though
from
I
October onwards, you didn't
kind
send
of
any.
suspect that some people are taking advantage. They are thinking, oh, the recordings are there, so I don't have to listen to the professor. That's not true. That will be harmful for them. But anyways,
Yeah, but the thing is, Professor.
Others, but we need recordings.
Yeah, I know. Yeah. Anyways, so do you guys have any questions so far? Because really, we have done a big part. The regression, we derived the formula. We also checked with numbers. So if you have questions, you can ask, or else I will call it a day today. And our exam is on the 20th.
Professor,
Yes.
can you also send these documents, like the ones you are discussing in the class?
Today, yeah.
Yeah, like the word document.
Yeah. That's what I'm saying. I'm going to share this Excel file and that this Word file. Okay.
Professor, also last class recording was not uploaded in Google Drive.
Yeah, I'll send that. I'll share that with the TS to ask them. Okay.
Thank you, Professor.
Any other questions? If not, I'll end the meeting today. I'm sorry again. We expect some basic thing from you. Okay, that's expected because it's an upper level class. Something has to be expected, or else I cannot start from scratch. I already spent more than a month to review probability statistics. Think about it. Now, do I have to review again from straight line? No, that's not possible. I did. Huh? Hello. Yeah.
Yeah, here you write I equal to 1, 2, 3, something like this. That means what I.
This is like here what are these eyes? That's what I'm saying. Eyes are like the observations, okay? 1, 2, 3, 4 up to n. So first observation, y1 equals beta 1 plus beta 2 x1 plus e1. For second observation, y2 equals beta 2 beta 1 plus beta 2 x2 plus u2, and so on.
Okay.
Yeah. Guys, okay now? Anytime, any question, you email me. So I'll try to answer, and I'll try to give some office hours before the midterm, not now. I know not now, you will be busy otherwise. Okay?
Okay, Professor.
All right. Can I finish this meeting now? End this meeting?
Yeah, Professor.
Yes, Professor.
All right, guys. Stay safe and enjoy your break if you have any.
Thank you, Professor. Thank you.
Thank you, Professor.
You are welcome. Say hi to your family members, okay?
Okay, Professor.
All right.
Professor.
See you after the break is over. Bye-bye.